This video is sponsored by Shapr3D. Hey guys, it is finally here, the Shapr3D Parametric Modeling beta that we have all been waiting for. So in this video, I'm going to show you how to design a piece of furniture from start to finish using Parametric Modeling. Now keep in mind, this is still the beta version, so not everything's finalized, but it's still going to give you a good idea on what Parametric Modeling is if you're not already familiar with it, and also how to use the new tool sets more effectively to improve your design process. And just so you know, this is a public beta that's available to everybody, so it doesn't matter if you're a current subscriber or if you're using the free version. Everyone can hop on and try it out. So if you don't have the beta yet and you want to follow along with this video, use my link in the description to download your copy for Windows, Mac, and iPad. And also, if you're new to this, might as well try it out. It's free. Who knows? Maybe you'll end up loving it. And also, if you do end up loving it and you want to upgrade later to unlock all the great features that it's got to offer, you can get 10% off the Pro version by using my code BevelishCreations10 at checkout. Okay, before we begin though, I just want to go over real quick what parametric modeling is and how that's different from the direct modeling method that's in the current Shapr3D that we're all familiar with, you know, where we can change the shape of a part simply by manipulating the model directly, like pulling and pushing on either a surface or an edge until we get the shape that we want. So it's just like playing with clay. It's a very straightforward and intuitive way to model something. Parametric modeling, on the other hand, is what's called a feature-based method that uses constraints such as dimensions or mathematical formulas to define the features and the geometry of a part, as well as its relationship to all the surrounding parts, meaning that everything is connected in some way. So if we make a change to one part, everything else is going to update automatically with it, which sounds amazing, right? But the caveat to this is actually there's a lot of upfront work involved with it, because every step that we take to get to our final geometry and all the constraints associated with each step is captured in a timeline. And the order of these steps is really important. So it's a very structured modeling method that requires a little bit of pre-planning for it to work effectively, which, you know, it's vastly different from the direct modeling method that I mentioned earlier, where we can just push and pull things until we get to the shape that we want. Anyway, I talked a lot, guys, so let me just show you. And oh, by the way, I usually design on iPad, but this time I'm going to do it on a computer because there's just a lot of little things I want to be able to zoom in and show you guys clearly. So let's go back to the home screen and we're going to create a new project. So usually when I start a new project, one of the first things I like to do is come over here and lock the grid size down to 1mm. It's just a personal preference. You don't really have to do it. Okay, let's create a new sketch. And we're going to select this front plane to sketch on, and we're going to draw a rectangle starting from the origin. So unlike in my past tutorials, this rectangle is going to set the parameters for the width and height of my entire project, including the top cabinet and the bottom legs. So we're going to set the width to 750 millimeters and then the height to 600 millimeters. And let's zoom out real quick. And we're going to select the entire sketch and turn on the horizontal vertical constraint, which just locks these lines down so that they stay horizontal and vertical, which I guess is kind of self-explanatory. Now let's select the entire sketch again, and we're going to turn the lines into construction lines, which means that these lines are now just used as reference lines and they're not going to interfere with the sketches that we're going to use later to create the 3D bodies. Okay, now even though we have the size and shape of the box locked down, it can still float around on this plane, and we don't want that. So come down here and click this lower left corner and select this little lock icon to lock it in place. And we only want to lock this corner down because we still want to be able to adjust the size of this box. Okay, so you probably noticed I've been emphasizing a lot about these constraints, right? Or at least compared to my past videos. And that's because in parametric modeling, our sketches are not directly connected to the 3D bodies that we're going to extrude later on. And those 3D bodies are then connected to other sketches and other bodies. So if one sketch isn't constrained properly and it gets messed up in an update, then everything that depends on that sketch is going to get messed up with it. So when we're dealing with parametric modeling, it is really important to get into this habit of properly constraining our sketches. Alright, so we've got our overall dimensions defined. Now we're going to draw another rectangle starting from this top left corner, and we're going to snap it onto this opposite edge. And make sure that's only snapping to this edge and not to this midpoint here. And also make sure that you see this little coincident constraint next to this point. This means that this point is now locked onto this line. So no matter how we drag this around, it can only move up and down this line. So in the future, when I say to snap a point to an edge, this is what I'm talking about. And it's really important to get this right. Okay, so this is going to be the cabinet portion of our model. So let's set that height to 350 millimeters. And now we're gonna come over here and pick the offset edge tool and make sure that the loop function is active. And we're gonna pick one of these edges and we're gonna offset that 20 millimeters. Now, one thing I don't like about this tool is that even though we just defined the amount that we want to offset, we still have to come in here and manually lock these dimensions down, which is just really redundant because we already defined the amount that we want the gap to be. But unfortunately, we can't skip this step because we're dealing with parametric modeling. So hopefully in the future, Shapr3D can fix this. Okay, so the last thing I want to do is draw some lines in here to connect our corners for our miter joints. Now, before we proceed any further though, I want to make sure that everything's behaving the way it's supposed to. So let's change the width to 1000 and cool, that looks good. Let's change the height to 500. All right, everything's scaling the way it's supposed to be. Now, if you're not getting the same results as me, just take a look at this and make sure your constraints look the same as mine. And also, if you're not seeing your constraints, come over here to the constraint settings and make sure that all the constraining and show all are both turned on. Now, I think it's really important when dealing with parametric modeling that we stop once in a while and check to make sure that the model is behaving the way that we want it to, because if we go too far into the design process and something goes wrong, then we have to spend some time to dig through the history tree to figure out what is going on. Oh, and one more thing, since we're modeling on the computer this time, I'm using my space mouse for all the navigation. So if later you see one of these things pop up on the screen, it's actually me pressing one of these hotkeys on the space mouse. It's not actually part of Shapr3D's interface. So guys, please don't freak out if you can't find it. Now, when we're using a tool for the very first time, I will use my regular mouse to show you guys where that's located in the menu. But then if we use it again, I'm probably just gonna access it using these hotkeys. It's just a lot more convenient for me. If you guys are interested to see how I have my space mouse set up to work in Shapr3D, be sure to check out the other video that I posted a couple weeks ago. And if you happen to be in the market for one of these, you know, I always got you guys. For a very limited time, you can save 10% by using my code Bevelich10 on 3D Connections website or by clicking on a link in the descriptions. And guys, if you're someone that designs on the computer, I highly recommend trying these out. It is totally worth it. Okay, anyway, let's get back to this. So let's undo a couple times so that we're back to the correct dimensions, and then we're gonna spin out of this view and start extruding these. Now, the problem with modeling this way is that if we try to extrude all 4 of these panels at the same time, it's going to create a single body, which is not what we want. So let's undo that. To avoid that, we want to extrude only the surfaces that are not touching. So let's do the top and bottom panels first, and let's do 500 millimeters. And then we can come back and extrude the 2 side panels. But we're only going to extrude halfway because I want to show you guys a really useful new feature that they just added. So let's come up here to this little clock icon and expand that to open up this history sidebar that shows us all the steps that we've taken so far to get to where we are over here. So we've got the first sketch plane, and then the first extrusion we made for the top and bottom panels, and then the second extrusion for the 2 side panels. And if we come over here and expand this, we've got a few different options on how we want to define the extrusions. Now, a quick note about this, the guys over at Shapr3D told me that they're still working on how this is going to look. So the final version is probably not going to have all these hashtags on it. And also they might be renaming what some of these options are called. So just keep that in mind going forward, especially if you're someone that's watching this video after the final version's already been released. Anyway, let me show you guys what these settings are. So the length and draft angle is just the depth and angle of our extrusion, which is controlled by these arrows over here. So it's the same thing as what we have in the current version of Shapr3D. But the new thing here is the bound type and bound object. So when the bound type is set to none, everything's controlled by the arrows over here. But if we change that to object, and then let's spin to the back, and then under bound objects, click on select, and we're gonna pick the back face of the top panel and click done. You see what I just did? Okay, so let's come up to the first extrusion that defined the top and bottom panels. And if we change this by pulling and pushing on this angle, our side panel is changing with it. It's pretty cool, right? Let's set that back to 500. So that is pretty much what the bounding parameters do. So what we just did here was create this relationship between all 4 of these panels. Now, it is important to note that with parametric modeling, we can't just grab a face directly on the model and pull that and expect everything else to change with it. Because if you look over here, when we did that, we just created a new feature under our timeline that happened after we already extruded our side panels. So currently, the side panel is still tied to these 2 steps that happened before it. It has absolutely nothing to do with this new step. But now let's say that we do want to bound the side panels to this new extrusion here. If we click on select, our new step actually disappeared. And the reason for that is, let's cancel real quick. And the reason for that is because this step happened after the side panels were extruded. So to make this work, we need to grab this step and move it before the side panels were extruded. But when we did that, our side panels disappeared and we're getting this error message. It's saying that there's a problem with the bound objects. So if we click on select, it's saying that this face that used to be here is gone. So all we have to do to fix this is select this new face and click done. And there we go. Okay, so now we can come to this first extrusion, we can make changes to it, or we can come to the second extrusion and make changes to it. So no matter what we do, the side panels are going to update with those based on the parameters that we already set. And this is what I meant when I said earlier that the order of our steps is really important in parametric modeling. We want to always be thinking about the relationship between parts as well as the order of operations that will make updating our models most efficiently. Okay, so let's hit undo a few times until we're back to just 1 sketch plane and 2 extrusions. And we're going to add a shelf in here now. So let's spin to the front because I want to show you guys a new thing that they added with this update. So if we click on one of these front faces and start a new sketch, remember how when we add a sketch to a plane that already has another sketch on it, it's going to combine all those into 1 sketch plane, right? Well, now let's exit this real quick. If we hide this first sketch plane, and we pick this face again to create a sketch, now we actually get a new sketch plane, meaning that we can have multiple independent sketches on the same plane, which is super nice. And I know this is necessary for parametric modeling, but hey, it's still a nice update. Okay, let's sketch a rectangle from the inside edge on the side panel, and we're gonna snap it to the opposite edge. And double check that you see these coincident constraints on both of these corners. And we're going to set the height to 20 millimeters. Let's double click on the sketch to select it, and we're going to turn on the horizontal vertical constraint. Last thing I want to do is set the opening height to 100 millimeters. Okay, let's spin out of this view, and we're going to pick this face and extrude it halfway. Then come over here to the extrusion options, change the bound type to object, and then we're going to select the back face of this top panel just like before and click done. And there we go. Okay, so just as a sanity check, let's go to the first extrusion and let's pull on this and make sure that it's updating correctly, which it is. And actually, while we're at it, might as well check this sketch as well. So if we change the width to 1000, that's updating correctly. And if we change the height to 500, okay, that's still staying 100, which is perfect. All right, so I hope what we've done up to this point gave you a good understanding of what parametric modeling is and how it works. And I know it can be kind of confusing and some of you are probably not big fans of it, but the good news is that Shapr3D didn't take away the direct modeling method. So we can actually just kind of ignore this history sidebar, pretend that it's not even there, and just go back to modeling the way that we used to. Everything still works, but that is not what this video is about. So we're just gonna keep going with this and add in some drawers. And also we're gonna turn it up a notch because there's gonna be a lot of stuff going on here. Let's exit out of the sketch and we're gonna make some inset drawers. So to do that, the first thing we're gonna do is come over here and add a construction plane. And we can either use this plane as reference or the front face of our cabinet. And make sure the type is set as offset from face and click next. And we're gonna offset this back 20 millimeters and click done. Now let's click on this plane we just created and we're going to draw a rectangle starting from this top left corner down to this bottom right corner. And this is going to be the border for our opening. Now, we didn't have to do this before because, let me spin out of this view and show you real quick. You can see that this plane is not laying on the surface of any of these parts. So we can't actually use these edges or the surface as our reference. But we do have access to these points, which are created by the intersection of these lines to our plane. And we can use those to create the borders that we need. All right, let's select our sketch and then come down here and turn on the isolate tool so that the sketch is the only thing we see. And let's go back to a front view. And we're gonna sketch another rectangle inside of this rectangle and make sure that we're not snapping to anything this time, because we're gonna come in here and set our own distances. So for the side gaps, we're gonna set those to 12 millimeters or roughly about ½ an inch, which is usually what we use for drawer slides. And then we're gonna set the top gap to 20 millimeters. And then the bottom gap is going to be 12 millimeters. All right, now let's double click to select the outside rectangle, and we're going to turn that into a construction geometry. And then now let's select both rectangles and make sure to turn on the horizontal vertical constraint. All right, so we're going to split this into two separate drawer boxes. So to do that, let's pick the line tool, and we're going to draw a line from the midpoint to midpoint of this inside rectangle. And we're going to draw another line above it, and then a third line below it. And then we're gonna pick the bottom and top lines and come over here and select the symmetry constraint. And then we're gonna use this middle line as a line that these two are gonna be symmetrical about. And now let's pick this middle line again, and we're gonna turn it into a construction line since we don't need it as part of the 3D geometry. And let's set the gap between the top and bottom lines to 20 millimeters. All right, now let's spin out of that view, and we're gonna select both of these and extrude those back 12 millimeters for our drawer box fronts. All right, now we're gonna go a step further and make the dados that the drawer bottoms are gonna sit in. So let's click on this left face, and we're gonna sketch a rectangle on both of these drawer fronts. And we're gonna set the dimensions of those to 6 millimeters by 6 millimeters. Let's do the same for the top as well. And we're also going to set the gap from the dados to the bottom of the drawer box to 12 millimeters. Once again, do the same for both of these. And we're going to spin out of that view, pick both of these rectangles, and push them out to get them cut. All right, so we're ready to move on to making the side panels for our drawer boxes, and we're gonna keep the joinery relatively simple by just using rabbet joints. But if you're interested to see more advanced joinery like dovetails and stuff like that, I actually have another video specifically on that, so be sure to check that out. All right, let's click on this left face, and we're gonna draw a rectangle, and this time we're gonna start from this top midpoint to this bottom midpoint. But before we click, we just wanna move our cursor toward the left so that it stays on this purple line. And this means that the height of this rectangle is now snapped to the height of this front panel. And once we've moved it outside the face of that front panel, then we can click to set it in place. And you know that you did it right when you see this little coincident constraint down here. And let's do the same thing for this bottom one. So move it along the purple line and set it in place. So basically what we just did here was we constrained the height of this rectangle to be the same height as these front panels. Now to constrain the length of these, we're gonna bring back everything else. So turn off the isolate tool so that we bring back the case, and we're gonna draw a line from this top back corner to the bottom back corner. And we're gonna pick this line and turn it into a construction line. Now we're gonna pick this line on one of these rectangles, and also select this construction line, and we're gonna set that distance to 25. And we're gonna do the same thing for this bottom rectangle. So 25. So this sets the length of these rectangles to always remain 25 millimeters short of the depth of this cabinet. So once we've done that, let's select the sketch and then turn isolate back on so that the only thing we see is the sketch. Okay, now let's select these surfaces, and we're gonna extrude those inboard 12 millimeters. All right, so those are our sides. And now just like we did for the front panels, we're gonna draw a couple of rectangles along this face for our drawer bottoms later. And we're gonna lock these dimensions down to 6 by 6. And we're also gonna set this gap from the dado to the bottom of the drawer box to 12 millimeters, just like we did earlier. And once that's done, we're gonna spin out of that and we're gonna pick these two squares and we're gonna extrude those back out. All right, so let's bring everything back, and this would be a good time to double check to make sure that everything's behaving properly. So let's go to this first extrusion up here, and if we pull this back, our drawer box sides should be scaling together with it, just like that. And while we're at it, let's bring back the sketch, and if we change the width here, it should be scaling as well. And let's check the height. Alright, I am so glad that updated correctly, because if it didn't, I would have to go back and figure out what happened and refilm that whole section of the tutorial, which would not have been fun. So, whew, what a relief. Okay, all that's left now is to make the other two sides of the box and then the drawer bottom. And guys, it's gonna be really quick this time. So let's undo this real quick. And we're gonna make two mid planes. One's gonna bisect the case this way and the other one this way. So for the first one, let's go under Add and then pick Construction Plane. Make sure the type is set to mid plane, and we're gonna pick this face and this face as reference and click Done. Now for the second one though, we're not gonna pick the front and back faces of the case because our drawer box doesn't sit in the middle of the case, right? So instead, what we're gonna do is pick one of these panels and we're gonna isolate it. And then go under Add and Construction Plane, pick mid plane, and we're going to use the back face of this side panel as reference and click Done. All right, now let's bring everything back, and now we're going to go under Transform and use the mirror function. And make sure that Keep Originals is on, and we're going to pick both of these side panels and this first mid plane that we made and click Done. And there's our two new side panels. And now we're just going to repeat the same thing for the front panels. So Transform, Mirror, pick the two front panels and then the second plane that we made and click Done. All right, so we've got our four sides. Now it's time to cut our joinery. So let's go under the Items Manager and we're gonna filter this to only show the bodies, and we're gonna select the first 8, which should just be our drawer box parts, and we're gonna isolate those. All right, now go under Tools and select Subtract. There it is. And make sure that Keep Originals of Removed Bodies is turned on. We're gonna pick the front and back panels first and make sure that they're all plus signs. And then we're gonna pick the side panels, which should all be negative signs. And click Done. And if we zoom in here, you can see that our rabbits are now cut. All right, now all that's left to do is our drawer bottoms, and these are really easy to do. So let's zoom in here, and we're just gonna pick this surface on both of these side panels, and we're just gonna drag these out. And then click on this little icon here, and make sure to make this a new body, and click out of it. Now let's go under the History sidebar and expand this last extrusion that we just made. Turn the bound type to Object, and then select, and then we're gonna flip to the other side and we're gonna pick this surface over here and click Done. And we only need to pick that once because this extrusion takes care of both of those panels. All right, let's zoom out and turn off Isolate, and let's bring everything back. And we're just gonna check to make sure that everything's scaling properly. So let's check that one, and well, it's kind of hard to see. Let's zoom in here, and we're gonna select both of these bottom panels and we're gonna change the color, orange. All right, now let's try that again. All right, it looks like it's working pretty well. Let's try the sketch. Let's do 1000 again. Yep, looks like it's scaling that way. Now let's do 500 this way, and looks like that is working too. All right, let's undo that, and all we got left now is to make our drawer fronts. Let's turn off this filter, and we're gonna hide all of these sketch planes and planes. Kind of all in the way right now. Now for the drawer fronts, let's sketch on this surface right here. And since this sketch plane is laying on the surface of our part, we don't need to draw that boundary box. So we can just draw this one rectangle in the middle, and then we can use those edges to set our gaps. And we're gonna set all of these gaps to 3 millimeters all around. And then we're going to use the same method as before to split this rectangle into two. So we're going to draw one line in the middle from midpoint to midpoint, and then one line above it, and then another line beneath it. Now let's zoom in here. And we're going to pick the top and bottom lines, use the symmetry constraint, and make sure that they're symmetrical about this middle line. And then we're going to select this middle line and make it into a construction line. This time we're going to set the gap between the top and bottom lines to 3 millimeters. And let's rotate out of that view, and we're going to pick both of these surfaces and extrude them back 20 millimeters. And there we go, that is our case. Guys, my beta just updated automatically, so now my interface looks a little bit different from what I had in the first half of this video. It's probably gonna look more like the beta version that you guys are running right now, and they also added some other features to this that I just haven't had time to test out yet, and I don't plan on going back and remaking this video. So we're just gonna keep marching along and make the base. All right, we're gonna start with the legs. So let's turn to the bottom face, and we're gonna draw 4 lines parallel to each of the 4 sides on this bottom panel. And also make sure that our lines are snapped to these edges so that when we're done, we should see the coincident constraint on all 8 of these corners. All right, now let's pick these lines, and we're gonna set the gap here to 20 millimeters. So 20 millimeters from the line to the edge that's closest to it. And don't worry guys, you'll see why we're doing this in a minute. All right, so once we're done with that, let's pick one of these lines, and we're gonna turn on the isolate tool. And let's select all these lines and make them into construction lines, and also turn on the horizontal vertical constraint. And we're gonna draw a line starting from this top left intersection and all the way down to this bottom right intersection. And now let's pick this line, and we're gonna offset this line 15 millimeters one way, and then 15 millimeters the other way. All right, let's zoom in here, and we're gonna draw a line that closes off this end, and we're gonna do the same thing on this other end. So now if we bring everything back, and let's select the second extrusion, if we change this, everything, nope, that's not what it's doing. You know what, I totally forgot that when we use this offset edge tool, we still need to manually come in here and select these lines and lock the dimension down to 15 millimeters. Completely forgot that I need to do that. All right, now let's try that again. All right, actually no. Better, but still not doing that because this top is not staying with that line. The middle line's doing what it's supposed to, but the rectangle is not following it. So I think what happened here was that we need to pick this point and then this edge, and we need to turn on the coincident constraint. And let's do the same thing over here, even though it's behaving correctly, but just in case. All right, let's go to the second extrusion again. Yep, that's what we wanted to see. So this is exactly why we keep stopping and making these tests, because if we kept going with this and we found this problem later on, it's gonna take us a while to figure out where this problem originated from, because as you can see, this history timeline, it's getting bigger and bigger, right? Okay, anyways, let's spin this out of the view, and we're gonna extrude this. Oh wait, actually, I need to turn this line into a construction line so that it doesn't split our extrusion. All right, now let's pick that again, and we're gonna extrude that down 40 millimeters. And since our sketch was laying on the surface here, we need to make sure to click here and change that into a new body. All right, so here's our stretcher. Let's click on that and isolate it, and we're gonna start making our taper legs. So let's pick this surface, and we're gonna start sketching a line. And actually, the first thing we need to do is define the ground line. So roughly put your cursor where the origin is, and we're just gonna draw a horizontal line out like this. Now, the reason why we can't snap to the origin is if we spin out of this view, you can see that our sketch plane doesn't intersect the origin. So we can't snap this point to it, but we can still define where this line is. So what we're gonna do is draw a line from this top corner of our stretcher down to this horizontal line. And we wanna make sure that this height here is 250 millimeters. And the reason we know this is 250 millimeters is if we bring everything else back and we go to this first sketch plane, We know that the distance from the bottom of this cabinet to the ground is 250 millimeters. So let's exit out of that sketch and let's pick this sketch again and our stretcher, and we're gonna isolate that again. So that's how we know that this 250 millimeters will set this line at the ground. So let's pick this line and we're gonna lock it in place, and we're also gonna make it into a construction line. And then let's delete that vertical line because we don't need it anymore. That was just used to define the position of this horizontal line. All right, so once we have that, let's click on the surface again, and we're gonna start drawing a horizontal line along the top edge of our stretcher. And make sure that both of these points are snapped to this edge and it's not snapping to any of these other points on here. And we're gonna draw a second line coming down at an angle and snap it to our ground line. And then our third line will be horizontal along this ground line. And then we're gonna come back up and close off our sketch with this fourth line. So once you're done, all four of these corners should have a coincident constraint. So now we can come back in here and we're gonna set the length of each of these lines. So this top line is gonna be 75 millimeters, and then we're gonna set this angle here to 97 degrees. And then this bottom line is going to be 25 millimeters. And that is the profile of our leg. And we want to lock it down so that it doesn't float around back and forth like that. So we're going to draw a line from this corner to this corner. And we're going to set that gap to, let's say 20 millimeters. All right, now let's click the sketch and we want to isolate that sketch. And let's spin out of the view, and we are going to extrude this profile out 30 millimeters. So the same thickness as our stretcher. All right, so we've got our leg, and now we want to make some bridle joints. So click on this top surface, and we're gonna start sketching a line. The first one's gonna go from midpoint to midpoint here, and then we're gonna draw another line on this side, and a second line on this side. And like before, make sure that all these points are coincident along the edges. And we want to make sure that these two lines are symmetrical about the center line here, and that all three lines are parallel to each other. And now we're going to set the distance between these two outside lines to 10 millimeters. And let's draw a line to close off both ends, like that. Okay. And let's select the center line and make that a construction line. And let's rotate out of that view. And we are going to extrude this down 40 millimeters. So same as the height of our stretcher. You can see that we still have some material left here because our leg is angled. So we can just zoom in here and select that face. And we're just gonna push it out to clear out the material. All right, now let's turn off isolate and bring everything back, and we're gonna mirror this leg over to the other side. So we're gonna need a midplane that bisects the stretcher. So let's create a new plane and make sure the type is set to midplane, and we're gonna pick this face and this face of the stretcher and click done. So now let's click on our mirror tool, double click on our leg, and select this new midplane that we just created and click done. And then now we're going to use the subtract tool to create the joinery for the stretchers. So let's pick all three of these guys, and we're going to isolate these. Now pick the subtract tool, and we're going to select the stretcher first, and then the two legs, and click done. And you see that we still have some material left on the ends here, which we can just get rid of by selecting these faces and push them out. All right, now if we just select the stretcher and isolate that, you can see what that looks like now. And that's it, pretty easy, right? Okay, now let's bring everything back. We're gonna use the mirror tool again to mirror this whole assembly to create our second pair of legs. But this time we're gonna need a midplane that bisects the cabinet this way, which I don't think we've made yet, so let's set the type to midplane, and we're gonna use the front face and back face of our cabinet and click done. All right, let's use the mirror tool again. Let's select the leg, select the stretcher and the other leg. And then we're gonna pick this new midplane here and click done. All right, that is it. Now let's just double check to make sure everything's updating correctly. So click the second extrusion, and if we pull on it, that's scaling the right way. Now let's go to the sketch and just make sure that this is scaling along the width as well. All right, looks good. Oh, and also let's check this height. So if we change that to 500, oops. And what if we made that like 250? And that looks pretty good too. And I hope you guys are getting the same results, because at this point, our design is pretty much done. Now, I did leave out the joinery for the shelf, so right now it's just kind of floating in there, which I actually did on purpose because I want to show you guys some of the tools and features that we can use when we need to make changes late in the design. So if we take a look at our history tree right now, there's just a lot of stuff there, right? It's kind of hard to tell like what's related to what, so we don't know where we need to start making our changes. But one of the features to make that easier for us, which you probably already know this, is if we pick a single part or multiple parts, the history sidebar updates to only show us the steps that we took to just create those parts. And then all the unrelated parts are hidden, kind of like the adaptive UI, right? So if we want to make a change to the shelf, we can double click on that and we see that it's created using the sketch plane and this extrude. So we know that the changes that we want to make to this guy should be inserted under this last extrusion. So the way to do that, instead of adding the steps at the end of the timeline, is by clicking on this little button with the 3 dots and then click on Rollback. And when we did that, you see we added this thing that's called a breakpoint. And if you look over here on the design area, everything that happened after we created this shelf is gone. But don't worry, nothing's actually deleted. If we just click on an empty space over here, you see all those steps are still there. They're just grayed out. So what we can use this breakpoint for is we can move these down one step at a time or multiple steps, so that we can see how this model was created in a chronological order, which is really helpful if you're trying to fix a problem and trying to figure out where the origin of that problem was. And also, if you happen to be working on someone else's model, you can see all the steps that they took to create that model. So the uses for this is very vast, but the way we're going to use this is wherever we place this breakpoint is where all the new steps will be inserted. So we're going to move this right underneath this last extrusion for the shelf. And let's isolate that shelf so we can create some tenons on the ends. And we're going to start by creating an offset plane from this front surface. And we're going to offset that back 25 millimeters and click done. All right, now we're going to sketch a couple rectangles on the ends here that snap to the top and bottom corners of this shelf. And we're going to do that to both ends. I'm going to set the width to 10 millimeters for both as well. And let's also double click on both of these rectangles and make sure to turn on the horizontal vertical constraint. And we're gonna spin out of this, pick both rectangles and extrude them back. All right, now come under the extrude options and we're gonna select the bound type to object, and then we're going to select the object as the back face of this cabinet and click done. All right, so right now we have 3 separate bodies. So we're going to pick all 3 and then come over here and use the union function to combine them into one. All right, so we've got our tenons. Now let's bring everything back so that we can cut the dados into our side panels, and we're going to use the subtract function for that. So we're going to pick our side panels first, make sure that they're both plus signs, and then use the shelf as the cutting tool and click done. And now let's get rid of our breakpoint, and there it is. And you can see all the steps that we took to create this new joinery are inserted in the proper location in this tree. So I know this example is probably not the best at showing how important this feature is, but like I showed you in the beginning of this tutorial, the order of our steps is really important for how our model will update. And this is one of those features that can help us with that when we need to make changes late in the design. Now, another tool under this menu is called suppress, which we can use to turn off certain features. So let's say for some reason that we don't like this mortise tenon type of joinery for the shelf, and we want to go back to using pocket screws. Then we can just double click on the shelf, we can find the steps that we took to create that mortise and tenon, and then suppress it, which also in turn suppresses all the children that depended on it, because now these children have nothing to depend on. That sounds kind of sad. Anyway, you can see in the model, our shelf went back to the way it was, and the dados in the side panels are also gone. So this is a really great way to check different design ideas. And let's say that our client came to us with a late change. And we made this change and gave them a new quote. And they're like, oh, no, never mind, this costs too much. And so we can just come over here, we can suppress it and go back to this original design without deleting anything. And then say after an hour, they come back and say, never mind, I really like that new design. I got the funding for it. Let's move forward. Then we can just come over here and bring everything back like that without needing to go back and remodel anything. And another great use for parametric modeling after the initial design for us woodworkers and makers is for creating cutting diagrams. And this video is already pretty long, so I'm not gonna go into detail on how I do that. If you're interested to see that, check out this video here. The process is exactly the same, but I do wanna show you what we can accomplish now with this update. So let's pick the 4 panels on our case, and we're gonna move a copy of these over here. And let's pick the side panel, drag this move tool down here so we can rotate this guy about that axis and lay it flat. And we're gonna repeat the same thing for over here. You see, direct modeling still works. Whatever we're doing over here is not affecting the main model because everything that's happening is happening at the end of the history tree. All right, now let's spin this guy 180 degrees. And then we're gonna align this to the side panel over here. All right, now pretend these 4 panels are laying on a sheet of plywood. So obviously with this update, if we make any dimensional changes to our model, the cutting diagram is gonna update with it. And then we can go ahead and update our cost. But let's say that you're someone like me who sells plans instead of actual pieces of furniture. And when we make these cutting diagrams, we don't want those dados to show up, right? Because it's kind of messy. So what we can do is come down here and select this first transform, which is the parent for all these other panels. And we can move that up above the step that we took to cut those dados. And there we go. The dados are gone, but if we make any dimensional changes to our model, the cutting diagram is still gonna scale with it. So yeah, I hope this helped to illustrate how useful parametric modeling is from the initial design all the way up to manufacturing. And like I said in the beginning, it does add a lot more work up front, but it's gonna make things a lot more efficient later on. Whereas with direct modeling, it's really easy and straightforward up front, but then can make late changes really tedious updates. So that's the main trade-off between these two. But the good thing with Shapr3D is we have access to both methods. So depending on what we're making, we can really use a combination of the two and take advantage of the best of both worlds. Anyway, I hope you guys found this video helpful, and if you did, be sure to give me a thumbs up and let me know in the comments. And if you haven't yet, be sure to hit that subscribe button and turn on the little bell notification because I've got a lot more Shapr3D tutorials coming, and I really hope I will see you guys in the next one.